Chapter 1.2 is a discussion on random samples. If you remember in 1.1, we talked about population, which is every person, every item, and samples, which would be a portion of the population. When you draw samples, there are different types of sampling techniques that are used, and that's what we're going to talk about. So the first type of sampling technique is what we call a convenience sample, and it's just as it states. It's what is convenient. Use population members that are readily available. Use whatever is handy. Unfortunately, this is the worst way to sample. An example of a convenient sample would be if I was doing a study on NOC students. If I had a room full of students in a particular class, I could just ask them because it's easy, it's quick, it's handy. So that would be an example of a convenience sampling technique. The next type is systematic, and this is where members of the population are sequentially numbered. Then from a random starting point, you choose every kth member that is included in the sample. So if I had a conveyor belt, which that is a belt that just moves, and let's say I had, don't have great art skills. These are supposed to be bottles. So if we had a whole bunch of, art is not my thing. So if you just had a whole bunch of different bottles and they were going across a conveyor belt, and say we just kept doing this. So what we do is we would have a random starting point, and we'd say we will choose every 5th bottle. So we would go 1, 2, 3, 4, 5. That bottle would go into my sample, and then I would count again. 1, 2, 3, 4, and then the bottle here would go into my sample. And I would keep doing that and choose every 5th bottle until I had a sample of, say, 20 or 25. That would be an example of a systematic sampling. The third type is stratified, and this is where the entire population is divided into groups, also known as stratum, and then samples are drawn from every group, which what this means is you have representation from every group. So if we divided students into their classification, freshmen, sophomore, juniors, and seniors, and notice there's an arrow from each one, and that would be if you chose 5 freshmen, 5 sophomores, 5 juniors, and 5 seniors. So you would have 20 people in your sample, and you would have representation from every group. That is stratified. Then we have what is called cluster, and this is when the entire population is divided into geographic regions. These are known as clusters. A few clusters are selected, and every member of each cluster is included in the sample. So if you'll notice here, they're divided up into school districts. So if you're in a town and it was divided up into its particular school district, but notice the arrows are only coming from school district A, C, and E. So what that means is everybody living in District A, District C, and District E are in your sample. Nobody from these other districts are in the sample. So, although both of these types are divided into groups, here they are placed into a group based upon a common characteristic. Here they are placed in the group geographically. In stratified, you choose someone from every group. In cluster, you do not have someone in every group in the sample. So be careful, these two are the ones that are most often confused. Then the last sampling technique is what we call a simple random sample. And this is when every individual of the population has an equal chance of being selected. This is the best method. The most common used of this would be a computer program that would just randomly spit out so many people or items. Now, if you did not have a computer program to do this, then you can use what is called the random number table. The random number table is found in the appendix of your ebook. So if you go to your ebook, you can find this. I've actually printed it off. And Appendix 2 tables, it says random numbers, and it is appendix page 9. And then these numbers up here, it's appendix page 10. So it's table 1 in your ebook. Now, if you'll take a look at this, this is your random numbers, and notice they're all 5-digit numbers, and we have white and we have pink. And these are what we call blocks. So like if I was talking about this number right here, 73780, I would say 1, 2, 3, 4, 5, 6, row 6, block 1, 2, 3, 4, 5. So that might be my starting point. Row 6, block 5. So let me show you how the random number table works. Suppose that we want to get a simple random sample of 5 students from a class. So let's say that we have a class size of 65 students. So what we would do first is we would number those students from student 1 all the way up to student 65. So we would first sequentially number them. Then what I want to do is I want to ask myself, okay, what is the smallest number to be chosen? And that would be student 1. And then the largest number associated with a student would be the number 65. Now, the key with random number tables is that you will be dividing the numbers into particular digits. And when you do this, it has to be consistently the same number of digits. I think that's an A. There we go. Consistently the same number of digits. And here's what I'm saying. 1 is a single digit, 65 is double digits. You cannot divide your random number table up into single digits and then all of a sudden start doing it in 2 digits. So what we have to do is we have to look at the number 1 as 0, 1. So now it appears as a 2-digit number, but we have not changed its value. All right, so here's how it works. We're going to be looking for numbers from 1 to 65. So you just randomly start at a starting point on the random number table. And they could drop a pin, or I just place my finger down there. So this would be row 5, 10, 11, row 11, block 1, 2, 3. So I'm going to start at row 11, block 3. Now what I'm going to do is I'm just going to write these numbers out. So let's see, my first one is 25296. The next number is 28387. The next number is 51350. And then the next one is 61664. Now, I'm going to stop right there. If I need to use more numbers, I need to pick up where I left off. So I would then use the 3, 7, 8, 9, 3, and I would continue. And then if this still needed more numbers, I would just go to the next line like we would if we were reading a book. But let's see if we have enough. All right, because this is double digits, my largest number, that's how I'm going to separate my numbers. And we're looking for 5 students. So I'm looking for from student 1 all the way up to 65. So I look here and I go, okay, there is a student numbered 25. So they will be in my sample. There is a student 29. They will be in my sample. 62 would be in my sample. So I have 3, I just need 2 more. Well, notice the next number is 83. Well, my largest number is 65, so that can't be used, so I throw it out. Here's 87, too big. Student 51 can be used, and student 35 can be used. And then once I get 1, 2, 3, 4, 5, I'm done. So these are the students that would make up my random sample of 5 students. Now, I just want to point out a couple of things to you. We did not need this student here, but here's how you get a single digit. 06 would mean to use student number 6. Also, this did not happen, but had, say, this number instead of 35, say it would have been a 25. Well, if I hit 25 here, I go, student 25 has already been used, so I cannot use that same student twice. So be careful of that. All right, another way that the random number table is used, and that is to simulate. And simulate means that you're basically going to not actually do the particular thing. So in this case, it's flipping a quarter 6 times. So I'm not going to actually flip a quarter 6 times. I'm going to simulate it by using the random number table. Well, this is a little bit different in that when you flip a quarter, you get heads and you get tails. Well, I need something to represent numbers because it's a random number table. So I could say heads is any even number, and tails could be any odd number. So I'm going to go to my random number table. I'm going to go to the second page, and I am just going to randomly start here. Whoops, that's not a very good spot. Here. Okay, so I'm row 5, 6, 7, block 1, 2, 3, 4, 5, 6, 7. Okay, so I'm row 7, block 7. So, row 7, block 7. And that number was 97310. The next number is 73894, and I'll go one more, 88606. So I'll put this back up here. Again, it was 1, 2, 3, 4, 5, 6, 7, row 7, 1, 2, 3, 4, 5, 6, 7. And I used this number, and this number. And I'll see if I need to use any more than that. Now, we only need even numbers and odd numbers. So I got to figure out how to divide these. Well, you could divide them by single digits. If you wanted to, you could use double digits. You could use a 3-digit number. It doesn't matter as long as you're consistent. I'm going to use single digits. And we're only flipping the coin 6 times. All right, so this number would represent flipping the coin once. It is a 9. 9 is odd, so that would simulate getting tails. This would be your second one, which 7 is odd. That would be tails. Wow, we have another odd, tails. We have another odd, tails. Then we have 0. Now, be careful on this, because sometimes people throw 0 out, but you have to think about this. If we did odd numbers is 1, 3, 5, 7, 9. So there's 5 odd. Well, then if you just did 2, 4, 6, 8, there's only 4 of those. 0 is considered an even number. The definition of an even number is it's divisible by 2, and 0 divided by 2 is 0. So this 0 would be an even number, which represents heads. And then we get 7, which is an odd number, which would represent tails. And we have 1, 2, 3, 4, 5, 6. So our random number table gave us a simulation of 5 tails and 1 heads. That is not what I would expect. When you flip a coin, you would expect to get 50-50. You would guess half of them would be heads and half of them would be tails. In this particular example, it did not happen. We rolled the dice so few times. If we would have rolled the dice 600 times, or not roll a die, sorry, if we would flip a coin, yes, if we would flip a quarter 600 times, then we would get closer to 50-50. Because the larger sample you do, the closer to 50-50 it would get. All right, I think, yes, that completes 1.2.